what would have happened is that the expression would have been a bit more similar all throughout. X over Y or Y over X all throughout, you know? And then they would try to force you to use this idea a bit more. Okay? Now, I can imagine that some of you guys might have just multiplied them across and try to figure out the value of X and value of Y, which is perfectly fine. But I have to tell you that the most effective way in this case would have been using this idea. All right? Now, let's look at the next one. So we have a couple more comments. So number I'm gonna go for number 7, and then I'm gonna go for number 3 and 4. Okay, so let's go for number 7 first. Now, when you look at number 7, it says p is equal to 2. What are the possible values of x? Now, hear me carefully, guys. Then this question now turns into this way: x minus 3 is equal to square root of 2 x minus 3. Are you guys good so far? Yeah. All right. Now, hear me carefully, guys. I'm sure many of you guys might notice I don't promote plugin that much, or almost never, except 3 cases. Okay, because I know that in many other places, like I mean, like big a couple places that I actually worked at when I was a college student, which one place was actually Kaplan, actual Kaplan place. The publishers, they actually have a SAT prep place, or at least used to in the city. So college that I went to, right next to it, they happened to have a Kaplan place. So I was trying to work there for, and then I ended up just didn't like it, and then I just came out. So places like that, they tell you to, one of the strategy is a back plugging, back solving. So they want you to, plug in the choices back into the equation and then do that for many, many, many questions. And I don't like that. If you are looking for the highest score possible, then back solving is not the case for the most part, except 3 cases. Except three. What are those 3 cases? I'm going to write them down. I want you to remember those three cases are fractional equation, radical equation, and absolute value equation. Those are the 3 cases where I want you to use the plugin method. You know why? Because when we are solving these questions at school, including myself, what do we ask you guys to do? We ask you to square both sides and find the values of x. Once you find the value of x or values of x, and I need you to plug those values back into the equation and check it. You see, we want you to check the answers anyway. Why don't we just check it from the beginning? As you can see in College Board SAT, usually what's happening is we only have like a few choices for us to check anyway. So from the beginning, just check it. And that is true for these 3 kinds of equations: fractional, radical, and absolute value equations. Is that clear, guys? If you have to be multiple choice questions. So my approach for you in this type of question is just plug in 3, 5, and 1. That's it. Is that clear, guys? So you know what? 3 seems to be very attractive. I'm going to plug in 3. When I plug in 3, my left side becomes 0. My right side is also becomes 0. Oh, it works. 3 is okay. How about 5? Because 3 is associated with 5, isn't it? What if x equals 5? Then what do I get, guys? 5 minus 3 becomes 2. And square root of 2 times 5 minus 3 becomes what? Another 2. Guys, are they equal to each other? Yes, it is. So 3 and 5 works. Therefore, choice A. Is that clear, guys? Yeah? So I didn't actually square both of them and then try to find the values of x, but chances are that you'll get 2 values anyway from there, and you have to check them up to see if they both work or not. So why not do that from the beginning? That's my argument. Okay. So remember, these 3 questions, only these 3 times. I don't ask you guys to plug in any other times. Okay, only these 3 cases you can plug it and then see what happens. By the way, how's my voice volume? Is that okay? Can you guys hear me okay right now?
Yeah, it's
Okay,
good.
good. Okay, thank you. Just wanted to you know, and then sometimes I become robot in the middle of the lessons, as you guys know, right? And you have no idea if I'm AI or real person. These days, when I see some TV shows and stuff, AI is actually very scary. They sing songs, they compose music. Uh, you never know. I might be AI and then just pretending that I'm Suk and then teaching you math. You never know. Chino is like, yeah, I think you're AI. All right, let's look at it, guys. It's kind of funny that some of you guys have I never seen you in person. You know, you're just a little picture from my Zoom window. It's funny. All right, let's look at it, guys. Next question. Now I'm gonna go for number three and then number four, and then we're gonna move on to the later questions here, right? So number three. All right. So here it goes, guys. Now I'm sure what many people have done would have been what many people would have done would have been that they would have what you call it uh, what you call it multiply them across and then find the values of x, right? That's what you would have done, which is perfectly fine. Okay. Now, so I'm gonna do that quickly, but at the same time, I'm just gonna give you another way for you to do it as well. I understand this is only number three. It's supposed to be a relatively simpler question. I get that, but I want to show you another strategy as well. So here, first, what we normally would have done, first method is multiply them across, so we get 3x plus 36 equals what? 21x. Would you agree? And then subtracting 3x from both sides, so we get 36 equals 18x. And what is x equal to? X equals 2. All right. And 5x there, which is equal to 10. We got that. That's done. All right, so we are done for the question. And if you have solved it this way, I think that's pretty good. But once again, I want to just give you another way of looking at it. This method is a method that which we don't teach at school regularly. Okay, but sometimes it's kind of quite useful. So I want you to have it in the back of your mind, back of your mind. Okay, watch this one. What I mean by that is this: if I have a over b is equal to c over d, by the way, when I have a proportion, did you guys realize that I can add up a plus c over b plus d? They are still equal to each other. Did you guys realize that? In a proportion, I can still add same number top by top and bottom by bottom. I still get the same proportion. Meaning this one applies for subtractions as well. Why am I giving you that? Watch this. 3 over x is equal to what? 21 over x plus 12. Would you agree? So guess what, guys? I'm going to subtract 3 and x. So what do I get, guys? 21 minus 3 over x plus 12 minus x. What do I get, guys? I get 18 over 12. Why do I do that? So that I can get rid of x here. Then guess what? Is 18 over 12 is equal to what? 3 over what value, guys? 18 over 12 is divided by 6. I get 3 and then 2. Haha. X equals 2. So therefore, 5x equals 10. Uh, I thought, what you call it, I'll just share with you. Whoops. My phone, I didn't call you my phone. What the heck? My phone just popped up and then I'll try to have a conversation with me. Anyways. All right, guys. So is this okay for you guys? Yeah? Just wanted to give you another idea. All right, let's look at the next one, guys. Next one is number 4. So here we have, what's the value of n? All right, so now what I can do is, in this case, simple way for us to do it is, I realize that n is equal to 3n. So just substitute that in over here. So we get 6n minus what? 24. So if you don't distribute, we tend to make a silly mistake over there, right? In place of n, I have 3n. Then I can subtract 3n from both sides. That should be equal to 24. So what's the value of n, guys? Divided by 3, we get 8. Hence, choice B would be the answer. How about that, guys? Is it okay? All right, let's move on to the next question. Number 11, I believe. 11 and 9, 11, 13, 15, 19. Okay, many odd numbered questions. All right, number 11. Number 11 is, in fact, a classic question that I need you guys to know how to do. We do this one a lot in school as well. So here we get 6 plus 3i over 2 minus 5i. In this case, how do you rationalize the denominator? That's what we are looking at, actually. We got to multiply by its conjugate, 2 plus 5i. Is that clear, guys? We got to multiply top and bottom by the conjugate of that. So then my denominator becomes 2 squared minus 5i squared. Difference of perfect squares, isn't it? So what do I get? That's 4, and that's 25. But we have I squared becomes -1. Don't forget I squared is -1, but I have another negative sign, so it's as if I'm adding them up. So the denominator becomes 29. The only thing that has denominator 29 is choice C. So I'm sure even if I don't multiply everything on top, I'm sure the answer should be choice C. Is that okay, guys? Alrighty. Now, let's move on to the next question. Number 13. So when you look at number 13, I like to share the idea of targeted multiplication. What do I mean by targeted multiplication? That is this. In order for you to get C value, how can you get C value? You gotta multiply inner and then outer and add them up. That's how you can get C value. All right. How can you get leading coefficient? That's when you multiply first by first. Oh, and then that 3 times something has to be 18. So A has to be equal to what? 6. How do you get the last number? Last number is last times last. That's the last number, which is 4 times what equals 12? Oh, B must be equal to 3. 4 times 3 equals 12. Once again, how do you find C? C is the when I multiply inner by inner and outer by outer and then add them up together. That's the middle term. So here I get 12x, and then A and B is multiplied to be what? 18. So 18x. 12x plus 18x, we get 30. Choice A becomes the answer. So as you guys can see, it's not just mere multiplying everything blindly. College board, they like to see things, targeted multiplication, I call it. They want you to target what you want to multiply by. Okay? Alrighty, guys, let's move on to the next one. Number 15. Now, this is also a relatively popular question on the SAT as well. So I want you to look at this one. 4a minus 2b equals 10. So when you look at that, there must be some sort of a relationship why they gave you this one. Meaning, how 4a and then 2b are related in a way that so that I can see. Oh, wait a minute. 9 is 3 squared. So you can rewrite this one as 3 squared to the a power, so that means 3 to the 2a over 3 to the b power. That's the question. But when you divide, what do you do with exponents? You gotta do 3 to the what? 2a minus b. You see? You gotta do the subtraction on the exponent when you divide. So what does that mean? It means, oh, wait a minute. 4a minus 2b equals 10, then what's 2a minus b? That's half of this. So therefore, you know that 2a minus b has to be equal to 5. So therefore, we get 3 to the fifth power becomes our answer. How about that, guys? You good? All right, so that was number 15. Now let's move on to the next question. Number 19. All right, number 19 was asked by many students. Okay, let's see if the answer key was wrong or something. We'll see about that. All right, as a probe descends to this particular place in Pacific Ocean, it records the amount of dissolved oxygen in the water in units of parts per million, ppm. Okay, the depth below 2,000 meters. At depth below 2,000 meters, the dissolved oxygen drops at a constant rate. Guys, on the SAT, when they say constant rate, guess what they're talking about? They're talking about y equals mx plus b. Okay, so d ppm for every change in depth of 100 meters. So slope is what? It decreases, drops, right? So negative d over 100. That's your slope until it reaches 0. At the depth of this much meters, the dissolved oxygen measured to be this much, 225. And then at this much, dissolved oxygen was this one. What's the value of D? So basically what they're looking for is, they're looking for slope, but notice the slope was in form of negative D over 100, right? So let's see what we end up getting, guys. So then it's going to be 65 minus 205 over this one minus this one, and this one minus this one. So what do we get, guys? Is that 500? Yeah? Then what do we end up getting, guys? So what is that equal to in the numerator? So we get 140, or rather negative 140, right? Over 500 has to be equal to this one. So then, simply put, then we get to realize that d over 100 is equal to 140 over 500. Of course, I can just divide this one by 5 to match with this. So what do I end up getting, guys? We get 100, divide this one by 5, then we get 28. So therefore, d has to be equal to 28. The 28 becomes our answer. Does that make sense, guys? Is that okay? Yeah. But the thing is, this question is in fact copy of another question that's similar. And in that original question, they talked about the depth was decreasing by 1,000 meters or something, or 1,000 feet. All right. So being able to express the slope, not in the value of 1 unit, but sometimes it can be expressed in the denominator value of 10 units, 100 units, or 1,000 units, any other units for that matter. Is that clear, guys? Now, on that note, I just want to remind you of one thing that we don't really talk about at school. I think I might have mentioned this one in one of the previous sessions. So what I mean by that is this: talking about the slopes. When slope is equal to a over b, then we should recognize that slope can be expressed as a over b, or a over b over 1, or 1 over b over a. So we can express slope in 3 different ways. What does the first one represent? As x changes by b units, y changes by a unit. Makes sense? Because change of y over change of x. Now, how about the second one? This is as x changes by 1 unit, y changes by what? A over b unit. That's the second interpretation of the same slope. How about the third one? As y changes by 1 unit, x changes by what? Not a over b, but b over a, the reciprocal. Is that clear, guys? So, so that's the interpretation that I need you guys to have. Now, as you guys copying this one down, I'm gonna give you one question that deals with this, because this is one of the popular uh, testing style questions in dealing with slopes. Mhm. All right. Now, if you guys got this one, I'm gonna give you the next. I'm gonna give you one question very soon. All righty, guys. So here it goes. So I'm gonna say, hey, uh, P is equal to point 0.3 K plus 10. I don't really care what kind of function this one is. I'm just telling you that there's a linear function, P in terms of K, and then it is written in this way. So I'm going to give you first conditions, and I need you to tell me what's happening with the second condition. So, for example, my first question is this. As K changes by 1, P changes by blank. I need to know, I need you to tell me what that is equal to. Second, as uh, P changes by 1, K changes by blank. All right. Third, as uh, K changes by 10, uh, P changes by blank. So I need you guys to tell me about these three things right now. Let me know what the answers should be for in each cases. Oops, sorry, wrong button that I pressed. If you have an answer for all three, let me know. Shoot it over to me, guys. All right. So I'm gonna get going little by little. Okay. All right. So uh, you have to realize that I can express my slope in three different ways. So first, point 0.3 can be expressed as what? 0.3 over 1. Or, what else can I do? 1 over 0.3. I have to get the reciprocal. Third, point 0.3 is 3 over 10. The fact that k is changed by 1, what am I talking about? I'm talking about when k is changed by 1, change of k, denominator is 1. So therefore, how much does y changes by? Y changes by 0.3. You see that, guys? Now, second, as P changes by 1, so what does that imply? When P changes by 1, the numerator has to change by 1 because that's the Y value, right? Then K changes by, okay, K changes by, as you can see, 1 over zero point 0.3 or 10 over 3 or 3.33. However, you would have seen the connection. Now, third, as K changes by 10, the fact that K changes by 10, we're talking about this one, denominator, because I was looking at zero point 0.3 can be expressed as 3 over 10. So therefore, P changes by what? 3. So you can see that the answer here was equal to 3. All right, so just wanted to give you just a little bit of different perspective on looking at the values. All right, guys. So now we finished going over section 3, I think. Right? I don't think there isn't any other questions. Alrighty, let me just check. All right, good. Can I just give you about 2 minutes at most? Look through what we just have done a little bit, and then we're gonna move on to section 4. All right. Just spend 2 minutes, just review through all the questions that we have done. Even if you got them correct, just remind yourself one more time. I give you 2 minutes at most. Look through your notes. All right, guys, let's look at the section 4. Which question or questions do you want us to look at? Can you guys type it up on the chatting, please? All right, if you have any questions from section 4, shoot it over to me. All right, I got some. 16, 19, 25, 26, 14, 29, 35. Okay, so we're going to be looking at those questions first. You let me know if you have any more. Shoot it over to me. 14. Okay, so I'm going to start with number 14 first. Okay, so I have some 13, 16. Okay, so let's look at these things together first. You know what? I'm going to start from number 13. And so I'm going to do number 13, 14, and then move on to 16. Okay, 13, 14, 16, and then 18. All right, let's look at that, guys. Number 13. Okay, here it goes. So here it goes, guys. Number 13 first. So Leonardo just bought a new boat whose value depreciates at the rate of 12% per year. So we see that over here, okay? The expression above gives the value of his boat in dollars after 2 years has passed. Which of the following expression could be used to determine the number of years it would take for the value of the boat to decrease by 25%? 25%, so that means what? 80,000 seems to be the original value, wasn't it? And original value actually has to be now decreased to decrease by 25%. So that means what? We gotta still have 75% of the value. Then what's the 75% of the value? So then I'm gonna do 0.75 times 80,000. And you get to see that this is 3/4. So we got 60,000. So 60,000 is the has to be on the one side. Okay, so then our answer has to be 60,000 has to be equal to this expression. Oh, there's supposed to be equal sign, I think, and then the answer is supposed to be choice C. How about that, guys? Because we gotta have one. How long will it be taking? Uh, the question is, we should find number of years you will take the decrease by 25%. Okay, so in fact, in this case, it would be there was a type. Maybe I don't think you were able to see it a little bit. 60,000, which would be 75% of the value. 80,000, and then 1 minus 12 over 100, 12% to the t power. So that's essentially what we're looking at. Is that clear, guys? Yeah? Yeah, I think when you look at the choices, it looks a little bit, because it looks like a minus sign. Did it look like a minus sign in choice C? Yeah, sorry about that. It should have been equal sign. So I think some of you guys might have picked a different one. And then choice 4 actually has 4 on top. So it was a little bit, awkward to look at. Sorry about that. Alrighty, guys. Yeah, I can say 13 was so they should have had an equal sign here instead of negative. Then it would have been all correct, you know. So I think this one was copied a couple of times, and then as it was being copied, it lost I guess what should I say uh some sort of a uh you know writing, and then it ended up being as if there was a subtraction sign when in fact it should have been equal sign. Okay. So now let's look at the next question, guys. What's the next question? Number 13 and number 14. Okay. So now, in case of number 14, so here, scatter plot. Okay, so as soon as you see the scatter plot, what do you realize, guys? I see a function that goes down this way. What kind of graph is this one? This seems to be the exponential function graph. So that means y equals what? Since it passes through 1, I'm looking for b to the x power, where b has to be less than 1, or in fact greater than or equal to 0 as well. And that's exactly fitting here. So therefore, our answer should be equal to a choice A. That's what we end up getting. Okay. All right. Let's move on to the next one. This is just mere recognition that this one looks like a what do you call it? Exponential function. Number 15, I believe. All right. Number 15. So I have a cylinder and then the cone. So Vladimir owns a food company that sells blueberry jam in 18 cubic inches jar. Okay, he makes his jam in a so large container that looks like this, composed of cone and a shorter cylinder body. Okay, with the batch of the okay, how many jars can fill? Uh, so in fact, this I'm gonna assume that whatever happens here, whatever happens here, entire containers will be going into the blueberry jam. That's what we're gonna assume. Okay. Because in reality, I don't think that actually happens. If I have like a certain container of blueberry, it gets concentrated a little bit when you make the jam. But we're gonna assume that there's a transition of whatever volume of jam that I mean blueberry I have, it's going to turn into the the bottle. So if you have to assume that, watch this one. One of the biggest things is I'm going to convert inches to the what? Cubic inches and then inches. But look at this one, guys. Our actual unit is cubic inches, not inches. So in fact, ultimately, what I need to do is this. My conversion factor is not 12 to 1 ratio. It's going to be 12 inches to the what? Third power is equal to 1 feet to the what? Third power. Okay, so that's what I need to do. So I'm going to calculate 12 to the third power. So 1728 cubic inches is equal to 1 cubic foot. So that's the conversion that I have here. Is that clear, guys? So now, another thing is I need to remember the volume of the cylinder. How do you find the volume of the cylinder? Volume of the cylinder is pi r square h, and volume of the cone is 1/3 pi r square h. So for the first one, the top is pi 6 square r squared times h, which is 4. Okay, and then the bottom one is 1/3 pi. What's the radius? Same radius here. 6 squared, and h is equal to what? 8. So I'm gonna add up these two things. So I'm gonna add them up with my calculator here. All right. So I believe that this one comes down to when I try to add up those two things, it's about 753.98. But the thing is, this is in cubic feet. 1 cubic feet is equal to 1728. So what I need to do is, this is cubic feet. I need to convert this one into the cubic inches. I have to multiply that by, not by 12, but by 1728. So then it becomes about 130,288 point something. But each jar has 18. So I have to divide this one by 18. The number of jars becomes about 72382. So what is that? About 72,000, which is choice D becomes the answer. How about that, guys? Is that okay? So that's basically what we're looking at for number 15. All right, let's move on to the next question. Number 16. 16 and then 18. It's back to back in that way. All right, let's look at number 16. All right, so number 16, a large group of students took a test. A median score was 75. Median is the middle, and then average score was 81. Now, what does that mean? Generally speaking, the median versus a mean, so it goes like this, guys. Generally, uh, imagine if my distribution was perfectly symmetrical. Okay, if my distribution is perfectly symmetrical, then guess what? Guess what you will be seeing. Median and mean will be right in the middle. Okay? Median and mean will be right in the middle. Now, but let me just give you one scenario. Is that okay? So what if you you know you went to work at a restaurant, okay? All of us are working together in a restaurant, and then we decide to get you know what, they're willing to pay us $10 per hour. Okay, so our average salary for all of us like $10 per hour. Okay, Lucia, you get a little bit more, so you get like a $10.50. Okay, Jin, you know what? I'm gonna give you 9.50 per hour. Okay, but just like okay, you know what? I'm gonna give you $11. Awesome. Uh, Jacob, I don't know about you, Jacob. I'm gonna give you $8. Like, but on average, we are getting around $10. Is that clear, guys? And then we have a superstar chef came in. What's the superstar chef? He always curses. What's his name? I forgot. He's a male chef from England.
Gordon Ramsay?
Yes, yes, Gordon Ramsay. So Gordon Ramsay decided to work for our restaurant, and then he's very expensive. And guess how much he gets paid? Let us say $1 million per hour. Okay, I don't know. I'm just making it up. Let's say he gets $1 million per hour. Wait a minute, guys. So that means all of us are getting about $10 an hour, but he's getting $1 million per hour. So what's going to be happening for average salary for all of us combined? Average. Average will no longer be $10 per hour. Average will be so much higher. Do you see what I'm saying, guys? Because average is based upon the sum of the salary that we all get all together in one hour. Because used to be it was like 12 of us put together, it's $120 per hour. But now because of him, we get 1 million $120 per hour. When you divide that by 13, oh, it's gonna be like near $100,000 per hour. We don't get $100,000 per hour. We get $10 per hour, people. Okay, meaning what am I saying? When there's an outlier, average always follows that outlier. Is that clear, guys? Average always follows that outlier. On the other hand, how about the median? Only because Gordon Ramsay came in and he gets $1 million per hour versus all of us getting around $10 per hour. Does the median change all of a sudden? The median is the middle number. Only because we have one person who's getting really, really high. Median doesn't change that much. Only the average. So what I mean by that is this. Watch this. Normally, if it's a symmetrical, mean and median is the same. But what if I have distribution that looks like this? Most of us are getting around here, and then we have very small group of people gets very high. Where is my median? Median is still around the center around here. That's the median. Where is my mean? Mean is over here. Mean always follows the tail. Does that make sense, guys? In my distribution, mean always follows the tail. So for example, I'm going to flip the picture here a little bit. What if we decide to take some sort of an what do you call that exam or so, and then what if ended up being that a lot of people scored very high? That happens. Very high. It was an easy exam, but I happen to have a couple of students who did very, very poorly. And guess what, guys? While my median score is pretty high still, median, the middle score, right? But my average will go down by far because of the couple of people on the lower side. Once again, what's happening, guys? Mean always follows the tail. That's just general description. I'm not sure how much of these things will be applicable for the question, but that is one thing that I need you guys to remember in terms of mean versus median. All right. So now, here a large group of students took the exam. The median was 75, while the average score was what? 80, 81. So what does that mean? That means there must be some students who got very, very high. All right. There's a small portion of the students who got very high. That's why it brought up the average above the median. So we're looking at more like this one. This is a 75, and then that's 80, 81. Okay. Then which factor, if true, best account for the difference between the average and median score? The most students scored in C range from, okay, that makes sense. That's pretty good. We have a lot more students who are scored around here. That makes sense. No students failed a test below. I have no idea if it's no student or one student. I know that a lot of students are near 75, but that doesn't guarantee that nobody got below 65, so we cannot say about that one. No students scored higher than 80. I have no idea. It can be a bunch of them might have been 81. 89, 89, bunch of 89s, and it brought the average to the 81. Or I might have had some students who might have gone over 90 as well. So I have no idea about that one. A few students scored much higher than the rest of the class. So in fact, uh, D is also true in this case. D is also true. Okay, but but the thing is, between A and D, now, this I don't really like the question in this case. I don't really like the question because both of them could have been the answer somehow, uh, accounting for a lot of students. But they're talking about the two different components. Only because average was higher than the median. What does that mean? That means I had a group of students who scored much higher than the rest of the group. So the best answer that describes the average being higher is in fact choice D because I had a small number of students who scored much higher than the rest of the class. That's why the mean was raised up. Okay, so that's why D would have been the better solution than A. But in terms of actual choices wise, A and D sounds both of them are pretty good, but D is more accurate in terms of raising the average to the higher end. Is that clear, guys? Once again, what I need you guys to understand is the mean always follows the tail, right? Mean always follows the tail. All right, that's what I want you guys to remember. All right, guys, let's look at the next one. Uh, Now, number 18 is the next one. All right, guys. How's my voice? Is my voice quality okay so far? Yeah. Okay. I didn't become robotic yet. Okay. Good. 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 All right. So here, Sheila had a bag of small candies, of which she gave away 70%. The fact that she gave away 70%, that means she only has 30% left, right? Her friend returned to Sheila the quantity of candies that was equal to 20% of the amount that Sheila had remaining after giving away. So this 20% was what? Based upon 30%. So she had X amount, but the fact that she gave away 70%, then she has 30% left. But based upon this one, her friend gave Sheila 20% of this one. What's 20% of this one? But the thing is, 20% has been added on to whatever she has. That means it's going to be 1.2. It's being multiplied. So, what is the original amount of candy in terms of what is the original amount of candy in the bag in terms of amount of X that Sheila has now? Oh, okay, never mind. X is the amount of candy that she has now. So original, let me call the original as O. Let me call it as R. Original. O looks like 0. So the original was R value, but since she gave away 70%, that's why she only has 30% left. But she got 20% of what she had. That's why we have 1.2 multiplied together. And then our final answer was X, which is amount that she has now. But the question is, how much did she have originally? So we just have to divide by these two. So original amount is what X over 1.2 and then 0.3. which is choice B. All right. So that's basically what we can do in number 18. All righty, guys. Let's move on to the next one. All right, just number 22, 23, 22, 23, and then 25. Okay, 22. Okay, 22. You know what? When I look at 22, as soon as I see this one, oh my, it's based upon really, really long reading. So in order for me to get this question correct, I better read this one very carefully. That's what I need to do. Okay, so I'm gonna try to focus on that one. So average increase per year. Guys, soon as I see the word average increase per year, that means a slope, essentially. In Algebra 1, we usually call this one as average rate of change. Average rate of change, okay? Average increase per year for the international tourist going to Germany uh, from here to here is closest to the that of what country? So 2010 to 2013. 2010 to 2013. So Germany is what? Where is Germany? Okay, Germany is. I'm looking at. What is the increase, right? But when they say average increase per year over 2 years, but I'm comparing everything with the other 2 years anyway. So it's not like one of them is based upon 2 years, another one is based upon 5 years, another one is based upon 1 year. Since they're not, it's not like that. Average increase to be similar, then actual increase for the 2 years has to be similar on the other aspects as well. So when I look at this one, 28 through 31 is about what? 3 million. So I'm looking for something that has about 3 million. United Kingdom, 62 to what? 69. That's more than 3 million, right? So that's not it. How about the next one? Next one is what? China. China is 57 to what? 55. It went down, so that's not it. France, 81 to, oops, 81 to 84. That's about 3. So France seems to be best so far. And I'm just going to check up on Spain later. Where's Spain? Spain is what? 56 to 60. That's in fact about 4. More than 4, isn't it? So our best answer should be France, which is choice C. How about that, guys? We just have to read it carefully in these kind of questions. Nothing much more than that. All right. Now, I can tell you, with certainty that if you are taking Algebra 2 right now, your question that you see from school are more difficult than most of the questions that you see from SAT. Do you hear what I'm saying, guys? The questions that you see from your regular classroom, if you're in Algebra 2 or higher, are more challenging than the questions that you see from SAT for the most part. But yet we struggle. Why? Two reasons. Because we forget the concept or we misread. Don't read it carefully. So therefore, when you get stuck, especially during the exam, what should be your first question to yourself instead of saying how can I figure this one out? Oh, let me try to read it one more time. Let me try to read it one more time. Is that clear, guys? That should be your mentality. All right, let's move on to the next question. So it was number 22. So next one is number 23. All right, so here, what do I get, guys? So I have some sort of table here, distribution of the test scores in Mrs. Keaton English class, which of the following set of test scores, if added, would change the standard deviation, standard deviation of the distribution the least. Oh, you know what, guys? I want to keep the standard deviation low. Then you need to understand what does it mean by having low standard deviation versus high standard deviation. First of all, let me just tell you what standard deviation is in a short form. Standard deviation standard deviation measures spread of the data from the mean. Okay, from the mean of the data. So in this case, where do you think my mean is at? Mean seems to be around 80. Would you agree? So my mean, the middle is around 80. So if I keep on adding the values away from the mean, then once again, low standard deviation implies that data are near average. All the data is congregated near the average. And then high standard deviation implies that all the values are what? Away from the mean. All right? So let's look at it, guys. 90, 99, they're all above the mean. 70, 80, 85. Oh, that's near the mean, so that's okay. Not bad. 100, 160, they're all very far away from the mean, so that's not it. 60, 66 is very low, but they're a lot away from the mean. So best answer was choice B because they're near the mean, which will increase the standard deviation the least. How you guys go so far? Yeah? Alrighty. Now, so next question is number 24. So in case of number 24, what's happening is, okay, so this is given. So this is given, they want to solve for r squared, right? They want to solve for r squared. How can you solve for r squared? That's rather simple. Did you realize that one of the operations that I'm going to give you is this? If I have a over b is equal to c over d, what are we normally, what kind of operation do we usually do in these kind of cases? We do the cross multiplication, don't we? But did you realize that not only doing the cross multiplication, did you realize that we can do cross exchange? Meaning in this case, I can swap diagonally. So I could swap A and D, so I get D over B is equal to C over A. Or I can swap the other two. A over C is equal to what? B over D. They are all the same. Not the ratio itself, but we are keeping the between the ratios, they're always equal. So in this case, I'm looking for r squared. Guess what I can do? Put it over 1, and then I'm going to do cross exchange f and r squared. Bam. Then what do you guys get? we get to realize that r squared is equal to g m1 m2 over f. Done. So what is that choice? B becomes the answer. How about that, guys? Is that okay? All right, so that was number 24. Let's go for number 25. In case of number 25, what are we looking at here, guys? Okay, planet Q, elliptical orbit around its star is shaped such that the farthest distance away from the is 3 times the nearest distance. Okay, so 3 times the nearest distance. Okay, if the gravitational attraction between the planet and the star is called G, what is the ratio of the G at this place and G at this place? So then, one is the closest, the other one is the farthest away, isn't it? So what do we end up getting? A is what? Farthest away, and then what you call it up? P is the what? Closest. So then, in fact, one thing that's going to be happening is this. Our formula is F equals G M1 times M2 over R squared. That's the formula, wasn't it? And you want to find the ratio. What's happening if distance becomes 3 times compared to the original? In this case, what you can do is this. You can keep things that are not changing as 1 as a constant. Whatever is changing, I want you to put that ratio into that expression. So what we end up getting is this: that G doesn't change, M doesn't change, M2 doesn't change, but R changes to 3, so 3 squared. What is that equal to? 1 over 9. So the answer is 1 over 9. Simple. That's what you can do and get the answers done right away. Now, but if you want to just look at this from a little bit more in general term, uh, what I would have done is this. Okay, F at A, let's call that as capital G M1 M2 over R squared. But the thing is, what is F of P is equal to G M1 M2 over what? 3 times of R squared, because 3 times of distance, because the one that's farther away. And this becomes G M1 M2 over 9 R squared. So we want to see the ratio between what? Uh, oh, actually, A is 3 times. So I have to swap these two. I got this is P, and then this is A. A is of 3 times away than P. So in that case, what do you guys get? I can set up the ratio of this one divided by this one, so we get G M1 M2 over 9R squared all over G M1 M2 over R squared, which now you become 1 over 9. So you could have done it this way. That's the this is a more like a regular solution that which you would have seen from the textbook or reference book, review book. Now, but this one is the what do you call that? Method that which you can use in the SAT. Alrighty, guys. That was number 25. You good? All right. Now next is number. Let's look at it, guys. 26. So we have a triangle and a circle. It's an equilateral triangle. So if the length of the arc ABC is 18, so that means I'm looking at this one, guys, here and here. That's 18 pi. What's the radius of circle? Oh, okay. And in that case, did you realize that in order for arc ABC to be 18, then each one has to be what, 9 pi? 9 pi. Then third one is 9 pi. So what do you guys realize? Circumference is equal to 27 pi. But how do you calculate the circumference? That's a 2 pi r. So you get to realize, oh, pi cancels away. So you get 2r is equal to 27. So r equals what? 13.5, which is choice C. So some people's cases, they might have confused that it was a 9, but in fact it was 13.5 because you have to go for the third one. Alrighty, guys. Now the next one is number 38. Okay. So it says Anthony deposited a $1,200 into the bank account that pays interest rate at an annual rate of 1.5%. Okay. Anthony's friend Sean found an account that earns 3% of interest compounded annually and made an initial deposit of $1,000. Okay, so we have two different amounts, two different rates. And then at the same time, Anthony made his. Okay, after 10 years, if neither of them deposit or withdraw, how much more money will Anthony have in his account than Sean? So in this case, what are we looking at, guys? What's the formula? Formula is amount is original principal times 1 plus r to the what? P power. That's a simple interest annually. So what are you going to do? In case of Anthony, it will be 1200 times 1 plus 0.015 to the what? How many years? I think there's 10 years, right? Oh, you cannot hear me. Okay.
Can you hear me better? Yeah, you can hear me? Okay. Yeah, so I think my system went out a little bit. Okay. Oh, so since I take away the earpiece, my head looks smaller. Oh, okay. All right, let's continue here. So that first one is this one, and then I believe it was what 10 years, wasn't it? So I'm gonna put this one into 10. How about amount of money for Sean? It'll be $1,000, and then 1 plus what 0.03 because 3% interest rate, right? To the 10. So I have to figure out each value and then find the difference. So I'm going to use the calculator to do it. First one seems to be around 1392. And second one is 1343. Oh, so what I'm going to do is I'm going to subtract first one minus second. I mean, I'm writing these numbers, but in fact, in my calculator, I carry the more digits. So I get 48.7. So to the nearest, what is that, guys? It'll be what 49. So 49 will be uh, to the nearest value. How about that, guys? Is it okay? Now, so what we're going to be doing right now is this. Since we have gone over this one, and then let's take about 5-minute break. All right, we're going to take a 5-minute break. During that time, I want you to just look at what we have done a little bit, and then we're going to come back and we're going to continue. We're going to go for topical. Is that clear, guys? All right. Yes. See you in 5 minutes. Alrighty. All right, everybody, welcome back. All right, so what I'm going to do is this. I'm going to share with you where I'll be looking at so that you guys can, you know, further ask me any more questions. So right now we're going to be looking at 2 weeks ago, I gave you topical homework. Okay, so let's try to look at it just one more time if there's any particular questions that you might have from there. So what I'm going to look at is, I'm looking at this one. Okay, so here we get, I'm going to go to the classwork, right? And then this is this week, but this is from the last week. From last week, when you look at homework number 1, that's the topical. So we have linear equations and then system of linear equations. We're looking at these two things, guys. So I'm going to look at set 1 first. All right. So I'm going to look at the first set. And then I'm going to ask you if you guys have any questions from set 1. Why don't you guys shoot it over to me from the from the chat, okay? Does anybody have questions from the linear equations section? All right. Okay. Number 11. Okay, and then when we have more questions from set 2. Yeah, we'll definitely go over that. Let's look at let's look at number 11 first, and then if you have any more questions from set 1, let me know, guys. Okay. All right, number 11. They want you to use the calculator for this question. So here it goes, guys. So Anarchy is competing in a 500-meter freestyle swim, okay, event, which consists of swimming the length of pool 20 times, okay. If average is what, 26.4 seconds per length, which of the following equation could be used to determine the number of meters m Anakin has left in the event after swimming for s number of seconds? So then, in fact, one thing that which we get to realize is this. All right, guys. So 26.4 seconds per length of the pool. So if you think about it, what is that, guys? 26.4 seconds equal to how many meters? Oh, I don't know. Oh, but it's one length. That means what? 500 divided by 20. So if you do 500 divided by 20, then that's 25 meters. Is that clear, guys? So what this person, this person's speed is, this person travels 25 meters in 26.4 seconds. All right. So what this person is trying to do is then, how about, what if this person swim s number of seconds? How much of a distance would this person swim by the time? So I'm going to call that as the d. Then you can see that the ratio is 26.4 seconds to s meters is equal to s2d. So I'm going to do, so we get s over d is equal to 26.4 over 25. So what I can do is, you can realize that, okay, 26.4d is equal to 25s. And then what is that, guys? D is equal to 25s over 26.4. That's the distance this person travels every second, or by the S number of seconds. But that's not what they're looking for. They're looking for is how many meters are left. So that means you need to subtract it from 500. That's why choice A would have been the answer. Because distance that the person traveled was this, but we have to subtract it from 500. Right? That's basically what we can do. Now, then let's, it seems like there isn't any other questions. I'm going to move on to the next one. Let's go for set 2. Do you guys have any particular questions from set 2? Shoot it over to me, guys. Okay. I have number 17 requested. Any other questions that you want us to look at? Come on, shoot it over to me, guys. From practice set 2. Okay, so I don't have any other, so I'm just going to get started with number 17 first. If you have more, you let me know. So here we have, in a college art class, 76 students are painting the mural on a wall, on one wall of the campus, and the wall has been divided into 23 sections. Okay, and then each section will be painted by a group of either 2 or 4 students. How many more sections will be painted by the group of 4 students than a group of 2 students? Okay, let me try to do this one. See if this one works better. Alrighty.
Can you guys hear my voice? Yeah, it's okay? Yeah. All right, so I'm just going from one device to another device to another device. All right, guys, so let's look at this one. Is the sound okay, by the way? The volume wise, is the volume okay? Loud enough? All right, good, good, good. All righty. Then let's finish this one up, guys. The total 76 students. And then we get to realize that, all right, there are 23 sections, and each group, each section will be painted by either groups of 2 or 4. So can I say we have T4 number of groups of 2, and F4 number of groups for 4. But when I add them up, I have total 23 sections. Okay? Now, but the thing is, total number of students wise, we have 2T plus 4F is equal to 76. That's essentially what we have. Can you see the setup? How many more sections will there be? Will be painted by a group of 4 students than a group of 2 students? Yeah. So that's what we have to look at. So then you can see that hey, you want to figure out the value of T and F. So what I'm going to do is I'm going to do this one by hand and also using the calculator. Because if it's a section of 4 questions, we can easily do this one with the calculator. Okay, so I'm going to do this one in both ways, by hand and with the calculator. All right, let's look at it, guys. So here we have, for the first one, how am I going to do this one by hand? I can multiply this one by -2. How about that, guys? Then I get -2t, -2f is equal to 46. And you can see that when I combine them together, we get 2f equals what, 30. Can you guys see that? Yeah? Hence, f is equal to 15. If f equals 15 from this equation, you can figure out that t must be equal to 8. So the difference is 7. Got it. We're done. But that's one way. But sometimes, especially in section 4, numbers sometimes can be ugly. So I want you guys to take out your graphing calculator, everybody. Some of you guys might know how to do this one, but I want you to just do it anyway as a practice. So what we want to do is we're going to solve t plus f equals 23, and then 2t plus 4f is equal to 76. That's what we want to figure out. So I'm going to take on my calculator as well, just like, but in my case, it's right over here. All right. Now, and then what I'm going to do is I'm going to share both. All right. So then what I need you guys to do is this. I need you guys to go to the matrix, and then I need you to put up the coefficients of these two equations into the matrix. So the way for you to get into matrix is second matrix right over here. And mine already says 2 by 3. 2 here means 2 equations, and 3 means 3 columns. And in order for you to edit the value, I have to go to edit, press enter. And I need to write down, if these two numbers are not 2 by 3, I need you to type it in by 2 by 3. Now what you'll be doing is, okay, I'm going to type in the coefficients. 1, 1, 23. Second one was 2, 4, 76. That's it. So first, I need you to put them into the matrix. Once you're done, I need you to go out of the matrix. Second, quit. And I want you to back to the matrix and then do the math. And go all the way down to RREF. I jokingly say it's a ref, double R, ref. But anyways, so now, and then I need you to put the what do you call that? The matrix back. So second matrix. In our case, from the names, you can just click on the matrix that which we are doing. Close parentheses, press enter. Boom, there it goes. And from here, it tells me that, hey, the first one, t is equal to 8, and second one, f is equal to 15. That's what they're giving me. All right, and then hence the difference is equal to 7. How about this one, guys? Is it okay? Once again, you should know both ways, using the calculator and also doing it by hand. All right? Okay, so we're done with this one. It seems like there isn't any other, there isn't any other questions. So therefore, I'm gonna move on to the next topic. By the way, in case, as you guys know, I'm recording this one. So in case when you got stuck and then don't remember what to do with your calculator, all you have to do is come back to this video, which is posted on our Google Classroom, and then follow through them one more time. Okay? Alrighty, guys. Let's look at the next one. So now today's topic, in fact, involves inequality. So let's see if you can finish the second one as well, or not. We'll see about that one. I mean, there are simple inequalities, but one thing that I can tell you is this: there's a few different kinds of things that which we're going to be looking at. Let me just give you this one first. Here it goes. If I were to give you, hey, 2x minus 5 is greater than 7, and then I want you to find x, that's rather simple. I know that you guys can do it. I want you to do it. But the second one is this. What if I want to say 2x minus 5 is greater than 7, but less than 11, and then find the x? How do you do this one? Right? So I want you to look at in both cases. As soon as you have an answer, shoot it over to me through the chatting. All right, I'm getting a couple answers. Nice. So, as you guys are doing it, more than anything, how do you approach this one, right? The how is a question that I'm looking at. So in the first case, all you have to do is just add 5. And then we get 2x, which is greater than 12. And then we're going to divide by 2. And x is greater than 6. Okay. But the second one is exactly the same. Instead of doing it in 2 sides, we're going to be doing it in 3 sides. So I'm going to add 5. That means I'm going to add 5 in it all throughout. Then I get 12, which is less than 2x, which is less than 16. And I'm going to divide everything by 2. Then I get 6, which is less than x, which is less than 8. How about that? You see? Now, that's one way for you to do it. But what if? So this is good, right? This is good. This is how we can do it. I'm going to give you 2 special cases. Now, number 3. What if x is not in the middle? What if x is in more than one place? Such as this one. Let me put it 21. Okay. How about this? In this case, how do you find x? So as soon as you have an answer, you let me know. In the middle is a 21, by the way. Okay, I see some answers. Very nice. So when you have these things, one thing that which we cannot do is we cannot multiply. Sometimes we cannot multiply, add, and do everything all at once in one location. In fact, what we need to do is we need to actually satisfy 2 at a time. One inequality with this one and another inequality with these 2. So let's look at the first one. So we get 2x plus 5 has to be less than 21. And I'm going to solve this. What do we get, guys? We get 2x is what? Less than 7. I mean, not 7, 14. I mean, 18. What am I saying? 18. That means 16. Ah, yeah, yeah. And then divide by 2, x has to be less than 8. So it has to satisfy this condition and another condition, which is right over here. 21 is less than 3x minus 6. What do I get, guys? When I add 6, I get 27. And then 3x. So when I divide by 3, then x has to be what? Greater than 9. Oh, wait a minute, guys. Which number is less than 8 but greater than 9? You see, when you have 3 things going on, and is assumed. Is there any such number that's greater than less than 8 but greater than 9? No. This is not possible. So our final answer would be no solution. Is that clear, guys? So when you have 3 things going on, it's always and is the connecting words. between those inequalities. All right, so now then we're going to continue on the same topic as to this. Watch this one, guys. Ready? Then we have number 3 is here. How about number 4? And then I'm going to give you number 5 right after. Okay, so here we have 2/3 is less than equal to n over 5, which is less than equal to 7 over 6. And I'm going to say find x. And number 5, I'll say 1/2 is less than equal to uh, 2 over n. Whoops. 2 over n, which is less than equal to 5 over 3. And then I want you to find n. So I want you guys to give me an answer through the chatting. There's 2 different questions, right? Okay, I'm getting some answers here, left and right. Okay, good, good. All right, I'm keep on getting answers. Good, good, very nice. Now, so let me now jump in a little bit. For the first question, it's relatively manageable for the first one because uh, when you compare fractions, we are trained to have the common denominators. You know, many times that's the first thing that we are asked to do. Okay, between 3, 6, and 5, what is the common denominator? Common denominator is in fact 30. So okay, let's do that. Let's make the common denominator 30. So we get multiply top and bottom by 5, multiply top and bottom by 6, multiply top and bottom by 10. Right? So that's good. Then I get to realize that 20 is less than equal to what? 6n, which is less than equal to 35. So I can divide by 6. So then you get to realize that n has to be greater than equal to 10 over 3, but less than equal to, what is that? Nothing. So 35 over 6. We got that. But the question for the second one is this. What if it's difficult because my unknown is on the denominator. So how am I going to make the common denominator? I mean, I could. I could do 6n, but did you realize that instead of doing that, we set up the common denominator so that we could compare them with each other easily. But did you realize that we not only we can set up the common denominator, but we can also set up the common numerator. How about that, guys? We could set the numerators the same and then compare what's happening. You know? So then wait a minute. Ah, 10 can be the common numerator. So I can multiply top and bottom by 2. Here I can multiply top and bottom by 5. And here I can multiply top and bottom by 10. Then what do you guys get? We get 10, 10 over 20, and 10 over 5n, 10 over what? 6. So 5n and 6 and then 20. In fact, since we're talking about the denominator, it has to be facing the other way around. Something like this. So n has to be less than or equal to 4, but greater than or equal to what? 6 over 5. So that's one thing that which we can do in terms of inequalities. How about that, guys? Is it okay? Now, so those are the a few things that I thought you guys can think about it in terms of its skills. Now, how about a couple other questions here? One of the popular ones these days that deals with inequality was something like this. They give you inequality. So what I mean by that is this. When you look at the question, guys, they are not asking you to actually sketch it. You just have to select. You just have to select the correct region that is the solution of the given inequality. So how do you do that? So why don't you try to do this question first? Okay, I have a couple answers coming in. Very nice. All right. So as you guys are doing it, and then most of them are correct answers. So one thing that which you guys can get to realize is this. What we need to do is we need to identify the line, and then we need to identify whether we're going to shade up or shade down. That's it. And you have to realize that when y is greater, then we're going to shade up. When y is less, then we're going to shade down. That's the idea. So here, when you have, oh, what does that remind you of? Oh, that means this is the line, isn't it? Y equals x. That's the borderline. Y equals x. And y is greater. So that means I'm looking at these sections. Would you agree? Now, next. Then this one must be this line. But look at this one, guys. Y is less. So since y is less, we're looking at this area. That means where is my solution? Obviously, my solution now is in this section, right? Which is choice D. That's what we can do. How about that, guys? Okay, so in terms of linear inequalities, what they're focusing on is not just actually graphing and then shading, but they're focused more on the shading component and identifying what the inequality should be. Now, how about this one, guys? So we've been looking at the inequalities with the three variables, right? I mean, three sides. Why don't you look at this one and let's see what happens. Okay, I have a couple more answers. Nice. Oh, okay. Now, so in this question, guys, uh, notice they're not looking for m. They're looking for 10m minus 5. Do you think there's a particular reason why they're doing that? Ah, because as you guys can tell, there is a relationship, which is how do you go from here to here? As a couple of you guys pointed out, yes, we're gonna multiply by -5. When I multiply by -5, then -2m becomes positive 10m, and positive 1 becomes -5. Then I gotta do that to all the other sides. So this one now becomes 25 over 2, and the other one becomes 7, right? But not only the inequality sign has to switch as well. So my 10m minus 5 has to be between these two numbers. So what is the greatest possible integer? This one is 12.5, so something that's less than 12.5 would have been in fact equal to 12. So that's why the answer D would have been choice D would have been your answer. How about that, guys? Is it okay? All right. So